Alright, so like I've mentioned before, resistors are connected in two ways. They are connected through the series connection or by parallel connection. These are the two ways in which they can be connected: series connection or parallel connection. So in our previous video, we've looked at series connection, right? Here we're going to look at parallel connection. So parallel connection is when two or more resistors are connected to a common terminal. So this is the common terminal here. This is the common terminal, right? So these three resistors are connected to this common terminal, right? They are connected to a common terminal. So let's say this is point A, this is point B. So the three resistors are connected to a common terminal. In series connection, the resistors are connected end to end. Here in parallel connection, they are connected to a what? A common terminal, right? So it's very important that you should know that different current flows through them. So it is different current that flows through resistor 1, flows through resistor 2, and flows through resistor 3. So if I have, for instance, a current of 5 ampere entering through point A different current will go to resistor 1, a different current will go to resistor 2, and a different current will go to resistor 3, right? So it's very important that you should know that different current flows through the resistor and they have the same voltage. They what have the same voltage. So the same voltage in resistor 1 will be the one for resistor 2, will be the one for resistor 3, right? So again, parallel connection is when two or more resistors are connected to a common terminal. This is the common terminal, right? And they have different currents that flows through them. Different currents will flow through them and they have the same voltage, right? All right, so the total resistance offered by these resistors will be 1 all over ROT. ROT is the total resistance, right? Equal to 1 all over RO1 plus 1 all over RO2 plus 1 all over RO3. This is how we calculate for the total resistance, right? So let's look at this question. Calculate the total resistance in the figure below. So you should know that this is a parallel connection. The resistors are connected through a parallel connection. Why? Because they are connected to a common terminal. This is the common terminal. This is the common terminal, right? So the total resistance, which is 1 all over ROT, will be equal to 1 all over 2 plus 1 over 3 plus 1 all over 2, right? So it is 1 all over 2 plus 1 all over 3 plus 1 all over 2. So this will be 1 all over ROT is equal to, the next thing I will do here is to look for the LCM of 2, 3, and 2. So the LCM of these three numbers is what? Is 6. So I'll put down the 6 there. 6 divided by 2 will give me 3, times 1 will give me 3, plus 6 divided by 3 will give me 2, times 1 will give me what? 2, plus 6 divided by 2 will give me 3, times 1 will give me what? 3. So this will be 1 all over ROT is equal to 3 plus 2 plus 3, that will be equal to 8 over what? Over 2 over 6, right? 3 plus 2 will give me 5 plus 3 will give me what? 8. So that's 8 all over 6, right? So what can go? 2 can go. 2 here will give me 4. 2 here will give me what? 3. So that's equal to 4 all over 3, right? So in other words, 1 all over ROT is equal to what? 4 over what? Over 3. So what do I do from here? The next thing I will do is to cross multiply, right? Is to cross multiply. So if I cross multiply, ROT times 4 will give me what? 4 ROT, right? Equal to 1 times 3 will give me what? 3. So the next thing I will do is to divide both sides of the equation by the coefficient of ROT, which is 4. So that will make my ROT to be equal to 3 over what? 4. This is my total resistance, right? So it's very important that you should know that in calculating total resistance for a parallel connection, it is 1 all over ROT is equal to 1 all over RO1 plus 1 all over RO2 plus 1 all over RO3, right? So again, parallel connection is when two or more resistors are connected to a common terminal. So they are connected to a common terminal, right? And different current flows through them. It is different current that flows through them, but they have the same voltage. So the voltage in R1 is equal to the voltage in R2, and it is equal to the voltage in R3. So it's very important that you should know that the total resistance is 1 over ROT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is the calculation formula for the parallel connection, right? Okay.